Now let's look at another wave phenomenon, which is called diffraction. What is diffraction? Diffraction is the spreading or bending of waves around a corner, an obstacle, or through a gap. First, let's look at the diffraction of water waves around a corner. When a series of plane wave fronts pass through a corner, the wave front will bend. In this case, we say the wave diffracts. Since waves carry energy, therefore we say the energy of the wave spreading away when it passes through a corner. For a shorter wavelength, the spreading is in a smaller extent. We say the wave diffracts in a greater extent. Now let's look at diffraction of water wave when it passes through a gap. When a series of plane waves pass through a gap, it diffracts as shown. Consider the case that the width of the gap A remains unchanged. When using water waves of shorter wavelength, the diffraction of the wave when passing through the gap will be less significant. However, if we use water wave of longer wavelength, the diffraction of the wave when passing through the gap will be more significant. Now, if we keep the wavelength of the water wave unchanged, if we reduce the gap width, that means we have smaller A, then the diffractions will be more significant. However, if we increase the gap width, then the diffraction will be less significant. As a conclusion, in order to increase the significance of diffractions through a gap, we may either use a longer wavelength wave or use a smaller gap width. when pink water wave pass through an obstacle, the wave front will bend at the two edges. Hence, the pink water wave still deflects in the region near the middle. For case 1, consider the barrier is between two regions having the same water depth. When the water wave enters into region 2, the frequency remains the same, the wave speed remains the same, and the wavelength also remains the same. Only the shape of the wave change, and this is the effect of diffraction. The wave pattern in region 2 will be and the wavelength of the water wave in both regions are the same. For case 2, if region 1 has greater water depth than region 2, when the water waves enter region 2, the frequency remains the same, the wave speed will decrease, hence the wavelength of the wave also decreases, and due to diffraction, the shape of the wave also change. And the wave pattern in region 2 will be something like this one. And the wavelength of the wave in region 1 is longer than the wavelength of the wave in region 2. Lambda 1 larger than lambda 2. Notice that in case 1, only diffraction occurs. However, in case 2, both diffractions and reflection occurs. There is reflection because the wave speed changes.